In this problem, we are given the circuit shown in figure 2 below, and we can use any technique of circuit analysis to verify the following equation. The equation that this is referencing is, of course, this one right here. Now, for this equation, we need to see if it fits with this entire diagram. Now, to do this, we are going to use the formula for voltage division. That's the formula right there, and now we can use it. Starting this off, we are looking at this formula. Normally it's V2 is equal to Vs, and this is being multiplied by R2 over R1 plus R2. However, our R2 in this case is going to be the resistance at this spot right here. We can see that this is our R2. However, since we have more to our diagram than just this, we have this entire part to the right of it, we have to combine it. We can see that our Rint right here and our R2 are both in parallel. What that means is that we can use the parallel formula for resistors in parallel right here to combine them together. And if we do that, we are going to get this equation right here, and that is our Rm. And our Rm, if we rewrite this equation to actually match our current diagram, is going to give us this. Now that we have that, we can plug it in to our formula for voltage division. Again, this is going to be the new formula for voltage division since we have an Rm, and we found our Rm right here because these two resistors are in parallel. Now we're going to plug our Rm into our Rm here and our Rm here. But actually, before we do that, what I'm going to do is cancel these out and just put this R1 over our Rm. If we do that, we are going to get this equation right here. From here, we need to plug in our Rm down here, so I'm going to do so, and that's going to give us this. Now we can factor in our R1 into this equation, and after we do that, we're going to get this equation. From here, we can cancel out the R2 for the first part, and then the Rint for the second part. So this is going to cancel out with this, and this will cancel out with this, of course, after we split these into two separate fractions. And that is going to give us this equation, which is equal to our initial equation. And that is how we would solve this lab problem.